Nice. Once we already changed the limits, we can overpower the x to the 2. We change the variable by naming x equals to v squared. We obtain the x equals to 2 times v dv. And to change the limit here, we need to know that this function is equals to the square of x equals to v. So
the new integral with the new variable should be x, which is v squared. So v squared, the x, it's 2 times v dv over 1 plus x, which is v squared over 2. So the new limit should be this limit inside this function. So the square root of 0 is 0, and the square of a, it's the square of a, so should be this. And now we can remove this square and move this to outside the integral. So we obtain the integral of, well, 2 times the integral of 0 to the square of a, b times b times b should be v squared dv over 1 plus v squared over 2. So we can use the trigonometric triangle. If we got this expression right here, 1 plus v squared, we can name this side like v, this side like 1, and that should be the hypotenuse, because this is a rectangle triangle. So that should be 1 plus v squared, and we know that the tangent of the angle we are looking for should be this side over this side. So it should be v over 1, which is v, I'm sorry. And we know that the angle should be the arctangent of v, so alpha should be sine minus 1 of v, and we can derive this expression. So we got the second square of the angle, derivative of the angle, and here we got the dv. So once we have this, we can replace this integral. We can get 2 times the integral from, well, let's say b squared, which is the tangent square of the angle. So the tangent square of the angle, dv should be the second, so times second square of the angle, the alpha. And below here we got 1 plus v squared, and that should be let me see, we can use we can use the identity, the fundamental identity of the trigonometry. So we know that if we got the sine of any angle, I mean the sine square of any angle, plus the cosine square of any angle, that should be 1. So we divide all of this by cosine square of the angle to obtain the tangent. So cosine square of the angle and the same as here, and the same as here. So that should be the tangent square of the angle. That should be 1 plus 1 equals to 1 over the cosine square of the angle. That should be the second, yes, the second square of the angle. So we know that v it's equals to the tangent, so v square is equals to the tangent square of the angle, and that should be v. Therefore, this entire expression here, 1 plus v square, should be tangent square of the angle plus 1, which is second square of the angle. So we can just replace this with the second square of the angle. We can that should be squared, sorry. We can rip off this exponent with this second, and we got the integral 2 times the integral of the tangent square of the angle over the second square of the angle, and the limit
should be these limits, but inside this function. So we know that the tangent and the arctangent of 0 should be 0. So the limit here should be 0, and the limit of the square root of we can the limit of the square root of a should be the tangent minus 1 of the square root of a. So yes, the tangent minus 1 of the square root of a. Now we can apply some algebra here. Tangent 1.
So we know that the tangent it's the sine over cosine of the angle. So we know that it's this, and the secant of the angle should be 1 over the cosine. So the secant square it's the cosine square of the angle, and that should be moved here by multiplying this cosine, so the cosine square of the angle, and we can just rip off this term, and we got 2 times the tangent minus 1 of the square of a from 0 to the tangent, blah, blah. So we got the sine square of the angle, derivative of the same angle. Here we can apply this identity. Sine of this angle should be the cosine of this angle times 2. So this angle times 2 over 2, like so. So we're gonna apply this and split it up the integral in 2 integrals. So let's say this is equals to 2 times the integral of 1 minus cosine of 2 times alpha over 2 to tangent minus 1 for the square of a. So we can split it up the integral by we can first move these 2 outside of the integral. So we got this here, and this is 2 over 2, which is 1. So we can just rewrite the integral from 0 to tangent -1 of the square of a, y minus the cosine of 2 times alpha, the alpha, and that should be the same as the same integral. Okay, this is the integral of 1
minus, sorry, the alpha minus the same integral, the same limits, but with this term. So the cosine of 2 times alpha, the alpha, and here we can solve this integral, and with this integral we need to use substitution. So let me see. First I'm going to write this integral. So let me see. So it will be alpha, alpha from 0 to the tangent -1 of this, and that should be, let me see. We know that if we replace the angle with u, the u should be 2 times the alpha. So we need to, the alpha is du2. So we need to add 2.
Yes, we need to multiply by 2 to solve this. So we are going to multiply by 2. Let me see. The integral from 0 to tangent -1 of the square of a. Now we apply 2 over 2, which is 1. The cosine of 2 to alpha, the alpha, and yes, we can move this outside. So this is equals to alpha from 0 to tangent 1 minus 1 over 2, and that integral should be integral from 0 to the integral should be minus cosine, minus sine of, yes, minus sine of the angle. Yes, minus sine of the angle, I think, like so, plus c, and no, it should be from 0 to the tangent of -1 the square of a. So to get this limit, we need to know the graph of the tangent and the arctangent. So if we know that the
graph of the tangent is something like this, the graph of the arctangent to be something like, let me see, like this, but inverted. So yes, like this. So we know that this limit here of the tangent is pi over 2, and this limit is minus pi over 2. So the range of this function also needs to rise the same limits of the domain here. So that would be the upside limit, which is pi over 2, and this is minus pi over 2. So if we need to know the limit of a when a second. Yes, we know that a tends to the infinity. So if we blow this here, we need to know the tangent of the square of the infinity, which is infinity.
and we know that if we take the infinity here, the function is pi over 2, so the limit also needs to be pi over 2. So this entire limit is pi over 2, and that means that also is pi over 2 because of the graph. So the function should be from 0, the tangent of 0 is 0, so this is 0, should be pi over 2, this pi over 2 minus 0, which is 0, and this it's minus 1 over 2 times minus the sine of 0 is 0, so the tangent of infinity, which is pi over 2, and the sine of pi over 2 is,
let's see, sine is the sine of pi over 2, which is this angle over here, should be 1. So if we know that the sine of pi over 2,
no, this is pi over 2, this is the sine of 2 times pi over 2, which is pi, and we know that the angle should be something like that, pi, this is pi, and the sine of pi should be 0, so this is 0, and 0 times 1 over 2 should be 0, so this is 0, and the integral should be pi over 2, I guess. Yes.